Once you made sure that YAME is able to receive the data coming from the simulator, you may want to set up your motion rig geometry. I'm going to show you how to do that. You just open modules and you go to scene view. And you're going to see this is a representation of your rig geometry. And you also want to open the rig config and probably also motion control, this one. So the first thing you should be aware of is the forward direction. You see these light green dots on this side of the rig, and they indicate your forward direction. You can also see it in the little coordinate system here. This is the direction you're facing. You can use the view cube, so if you click on B for like looking at the rig from the back side, so you see it from the behind, then from the right side or from the left side, you can take a look at your rig. And the most important thing is to note that the green dots represent the forward direction. So you want to set up your rig and define the rig geometry using the rig configuration window here. And you have distance A and distance B on your upper platform. That's your upper platform. And you have distance A and B on your lower platform. So what you should know is that the reference for A and B is always the forward direction. So between these two dots on the upper platform, that's your distance A. And also on the lower platform, which consists of these lower points, these 6 points, distance A is also the distance between these green dots. So in this case, on your lower platform, distance A is the small number, while on the upper platform, distance A is the large number. And then respectively, of course, the distance between these two dots, that's distance B. And on the lower platform, the distance between this dot and this dot, that is your distance B. So you want to measure your rig geometry depending on what hardware you're using for distance A and distance B. I'm going to show you a little sketch that would probably make it a bit easier. So here's a little sketch that indicates what I'm talking about. The upper platform, this is the forward direction, obviously, and on the upper platform, A is the large distance between these two connecting points, and then, of course, B is the distance between these two universal joints on the left and right-hand side of this arm. Similarly, on the lower platform, distance A is probably the small value indicating the distance between these two universal joints down here, and then distance B is the large number between these two universal joints down there. You want to enter these numbers into a distance A, distance B for upper and lower platform. I can give you an example. Like if I set this to 1500, it's going to make that upper platform much larger. If I also increase the upper B, for example, here, to something like 500, you see it gets even larger. But let's turn this back. So now everything is back where it used to be. The next thing you want to set up is your actuators. The first thing you need to measure is your minimum length. That's the length of your actuator from the lower to the upper connecting point, like the overall length of the actuator when it's fully retracted. That's a measurement you have to take off of your actuators. And then the stroke is the amount of extension that you can have. So in this case, 970 millimeters is the actuator in its fully retracted length. And then a stroke of 520 millimeters is the extension on top of that. And that's probably the number you want to take out of your motion controller, out of either the Thanos or the Motion for Sim controller. That's the value that you have set in this controller. So these three numbers, or actually these two numbers, are a bit tricky to explain. The park position is the height of the upper platform, like the center of this upper platform above the reference plane, when the rig is in its park position. As you can see right now here in motion control, it is in its park position right now, it's green. And this number indicates how many millimeters above the reference plane you want to park your platform. Now, the condition for parking your platform is pretty much your actuators being at zero extension. For example, I can punch a number in here like 850 millimeters, and then you see that this upper platform now jumps to 850 millimeters above the reference plane. But you see the color of the actuators is no longer in this light blue. And that's because right now they are extended more than their minimum length of 970 millimeters. So that's what this little calibrate button here is. If you want to calibrate the park position, that means the software will find the height in order for your actuators to be at their minimum extension and to within like 1/10 of a millimeter or so. So if you click the calibrate button, you see the platform will move to a point where they have exactly this length, and the platform is in its lowest possible position. So either you can set it manually wherever you like if you want to park your platform anywhere else, but most probably you want to park your platform at the lower end of the actuator travel. So that's what the calibrate button is for. The next one is your pause position. And to understand this, you may want to move the platform to the pause position by clicking on the pause button here in motion control. You see the two orange lights indicate that it's in transit, and now it reaches a state where it's in the pause position, or you may want to call it a standby position. So this is the place where the platform goes before the motion actually starts, and it's in the center of the envelope. And the center of the envelope is defined as the position in which the actuators are exactly at their 50% travel. And again, I can set this platform pause position. For example, if I set it to 1500, you can see that the platform jumps there, and you see red indicates that now the actuators are above their maximum extension, so that's a point they can't reach. But if you're unsure on where to put it, you can enter manual numbers here, but you also can use the calibrate button. That means the software is going to find the place where your actuators are going to be at exactly 50% extension. So I want to click the button, and you see at 1042 millimeters, 0.38 something, that's exactly where your actuators, at least in this configuration, have 50% extension. And it indicates as a little green actuator. So here's the color scheme for these actuators. If, for example, you're commanding the actuators to go to a position that they can't reach because it's just too low, they can't go this short, you see them in blue. That means they're underextended. This is a position that you can never reach. So if you give if you go to park position, calibrate, that means they are exactly at the 0 position. That's where they're supposed to be in the park position. Now, as an example, let's move them to the pause position. They are white. That means they are somewhere in between. Most of the time you'll see them in white. Green means they're exactly in the 50% position. And for example, if you have them too long, that means you're commanding the rig to go to a position that it can't reach on the long side. That means you see them in red. That means they're so far away you can't. This actuator cannot reach this position, so it's red. And there's something in between. It's an orange, and you see them in orange. That means they are exactly at 100% extension. But in order to have everything properly set up, go to pause position, then calibrate. That means the rig is going to jump exactly to the 50% extension position. And that's the position that you want to use as pause position or as standby position. Now put it back to park. And you can park the rig, and you see them light blue, and that's the position you want to have.